Hi guys, you're welcome to my channel. Alright, today class we're going to discuss about conductor color code, okay, our cable color code, because some change have been made since 2008 from our regulatory body, okay. Alright, so this update is because I got some requests from my followers to treat this particular aspect of electrical, okay. So, and you do not, I want to plead to you guys, do not think that we are trying to deviate from the channel objective. No, our objective still remain automation and control. All right, I give update based on request. Sorry. So we are not trying to deviate from automation and control. We are still doing our automation and control. But I just want to treat this so that those of us that are aspiring to come into electrical space will also get clarification. Okay. And some of us that are also aspiring to come into electrical design and drafting. Okay. So this is very essential to those guys for you to know your new color code. All right. And electricians and the student, where you are carrying out your troubleshooting, especially electricians, I want you to create this awareness to also be aware that color code have changed. Despite that some industry have not done their industrial revolution by changing some of their old installation to new installation, but you have to be conscious about this color code. Even if the some industrial setup they've not done their changes, but the new changes will take effect. What I mean is this: if your color code of old cable installation is still the lifespan are still there, it has not expired, it's not due for changing, there is no issue, you can be using your cables pending when the change will give rise, okay. But whenever I want to do advance, I make an alteration to your existing installation by adding new installations or installing new equipment. Whenever I want to do that, you should be able to work it to do it with a new color code, okay. Then I will also tell you how to merge the two color code together. Both of them can exist in an installation. You just have to do the right thing and follow the the due process, okay. All right, now let's discuss about the color code. Then pay attention, especially for electricians, we carrying out troubleshooting on in an existing installation that have the new color code in place, old color code and new color code in that same installation. So you should be safety conscious while doing your installation and your troubleshooting, so that you know that new color code and old color code exist. Some of them exist in certain installations. Okay, all right. Sorry. Then the old color code, as we are all aware, this is the old color code. Okay. So red, yellow, blue, black respectively, and these are their mark. Okay. And this is the voltage range as at then: 415 volts stroke 220 volts. 415 is our low voltage supply for three phase. 220 is our low voltage supply for single phase. All right. Then our color code for single core cable installation is this: either you're using red and black, or you're using yellow all through and black, or you're using blue all through here and black. So this is for single cable installation. Then for multi-core installation, this is what we have. I'm talking about our old color code. All right. Now the new color code have changed. Now our line 1 is brown, line 2 is black, line 3 is gray. Line 3 is gray, Gray. Then our neutral is blue. All right. Remember that neutral here is line 3. Here neutral is blue here is our line 3. Here now blue is our neutral. Okay. Also remember that line 2 here is black, but in our old color code, black here is neutral. So these are the changes you have to pay attention to. All right, these are their marks as well. Then the voltage range has also changed. This voltage range in practical, it may not be applicable to some industries. What I mean is this: if you have your national grid that has not been upgraded, it can be using your supply as 415 and 220. If your national grid supply have not been updated. Okay, this may be obtainable in some supplies, but the cable size, the cable color code will be changed. Please do well to change whenever your old color code expires, whenever your existing cable expires. Although all the cable manufacturers, all right, all the armored cable manufacturers, they've all complied to the new color code. If you go to the market to purchase this armored cable, you will find out that we are buying cable from the drum. What I mean, buying cable from brand new cable from drum. Whenever you are buying them, you will find out that this is the color you are going to get right inside the cable. You will no more see this because they've all complied to this particular change. Okay. But if you are buying the cable from a reclaimed circumstance, reclaim that you are buying a old cable, off-cut cable, old cable, reclaimed cable from some industries. You want to buy them from the market, there is a tendency that you are still going to buy the old color code because it's an old cable, reclaimed cable from companies or individual taking them to market to resell. You can still buy them when you buy them. But when you are buying from drum, brand new cable, you no longer see this color. This is what you're going to see. Okay. All right. So let's take note of that. Sorry. Then, if we are doing single cable installation, this is the format you're going to take. Okay, either you use brown line 1, line 2, line 3, brown color, same color, then blue for neutral, or you're going to use black, 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 and blue for neutral. Then for single phase, you're going to use brown and blue. So when you find these colors in your during your troubleshooting in electrical setup or electrical installation, please don't be scared and don't be confused. These are the new. This particular change has taken effect, has been taken has taken effect since 2008. Okay, since 2008. I don't know if it is possible to show you some books that will show you these changes. Okay, I have some books here. Although I'm a member of IET, like I told you before, I'm a member of IET. So these are the books for IET. This is my membership card, of course. So I have some electrical books to refer to you that you can buy whenever you are doing that. But let's concentrate on this particular. Let's just go to our whatever. Later, we recommend some books that will show you all the changes that has been taken effect. Okay. All right. Let's proceed. I think we are done with this. Then the voltage range. Oh, I told you that so many things has been changed since 2008. Okay. Let's discuss. We are done with the cable color code. Let's discuss about the voltage. The voltage now is 400 volts three phase supply, then 230 volts single phase supply. So your low voltage, if you are dealing with low voltage of 400 volts supply, our voltage range for three phase is 400 volts now, no more 415. Then our single phase low voltage supply is going to be 230 volts, no more 220 volts. Then generator manufacturers and the transformer manufacturers, they've all complied to this as well, especially generator manufacturers. If you check their alternator output, if you buy three-phase generator, three-phase diesel generator generating set, you find out that your output from your alternator has been regulated to produce 400 volts versus stroke 230 volts. That is what the automatic voltage regulator is set to produce. Okay, the AVR inside the alternator has been set and programmed to regulate the voltage at 400 volts stroke 230 volts. That is the updated generator generating voltage as currently as we speak. Okay, then your old gen set may be still having this setup. Your old generator set, you can still be using it. Okay, the voltage range change does not mean that your old generating set will be obsolete. No, it can still be working. All right. We still have a tolerant. We still have a tolerant within this voltage frame. Okay. We have tolerant plus and minus. It can still offshoot. The plus and minus, this can also be adjusted. All right. So we have tolerant. Okay. And then that is for color code. Then for we have a lot of changes in our regulatory from our regulatory body, that is our IET, Institute of Engineering and Technology. That is the governing body of all the countries that are using 230 stroke 400 volts. Okay, why NEC, National Electrical Code, they are in charge of regulating electrical installation requirement concerning 110 volts and 60 hertz frequency. Okay, our own is 50 hertz frequency, 400 volts stroke 230 volts. So the country that are under this frame of generation voltage range will be governed by IET. Okay, so we also have this change made since then. A lot of change has been going on, as taking effect. That is why I want to recommend the books to technicians, especially students, so that you'll be aware of whenever you are carrying out your design. Okay, so let's discuss about the voltage drop. Our permissible voltage drop. Okay, listen, I said our permissible voltage drop. We have 5% for power circuit, we have 3% for lighting circuit, then we have 4% for your installation, your setup, your entire system installation. Okay, let's take for instance, I have an induction motor. My induction motor is set to operate at 400 volts to 380 volts. So that 380 volts is the minimum voltage allowable for the motor supply to the motor to work efficiently and optimally. Make sure that your induction motor voltage supply to the motor will be regulated within 400 volts to 380 volts. Okay, so the voltage drop should not exceed 380 volts. That is what this voltage drop is telling you now. Okay, let me show you something. If we are going to work within this 5%, that means what they are telling you is practically not to exceed 380, because 380 is the minimum that voltage drop is permissible. Okay, so let's do that now. Supposing I have a power circuit of an induction motor, and we are instructed from the stipulated guide not to exceed 5%. So how many volts are we talking about not to exceed? It's going to be 20 volts. Let's do the calculation. All right. Now let's use calculator. I have 400 volts and we are told not to exceed 5%. So 400 divided by 100 times 5, that is 20. So if I have 400 volts supply at my power circuit, make sure that voltage does not drop more than 20 volts. That is what it implies. I have three-phase distribution. Make sure that the distribution of that three-phase does not drop more than 20 volts out of 400 volts. That your nominal supply, okay? 5 volts, 5% of your nominal supply shouldn't go below that. Okay, that is what is implied. So if I have 400 volts, the voltage shouldn't drop more than 20 volts. Okay, now for the case of 230 volts single phase, if you are working with single phase, that is 230 volts, it's also 5%. It shouldn't go below above 5%. So in that case now, let's say we have 230 is going to be divided by 100 times 5. All right, so our 230 volts should not drop more than 11.5 volts. If you are working with 230 volts and you are supplying power circuit, you are supplying power appliance or equipment that is a power equipment. So the voltage drop within that your supply, within that your circuit should not go above 11.5 volts. Okay, all right. Now let's say we have this 230. We now say okay minus 11.5. Okay, so our equipment on single phase is going to work optimally and efficiently if we regulate our supply within 218.5. So your voltage shouldn't drop more than 218.5 volts, 218.5 volts. Then in the case of in the case of 400 volts, if I have 400, I said, okay, I minus 20, I have 380. So your 380 should be what you're going to be maintaining within your power circuit. Okay, if you are working with 400 volts. So that is what it implies. So make sure that you regulate your power, you manage your power supply on three phase, not to drop more than 380. Okay, and make sure you also manage your single phase voltage supply, not to drop more than 218.5 volts. Right? Okay, now that is what it implies. So the same thing here is for your lighting circuit, it's going to be 3%. Okay, so 3% of if I have 400 volts, I said okay, divided by 100 times 3. So if I'm working with lighting circuit, my voltage drop shouldn't exceed 12 volts. Remember, it was 20 volts when we are working with 400 volts for power circuit. Now they are telling us not to exceed 12 volts voltage drop. So in that case, our lighting circuit is going to be 400 minus 12. So make sure you regulate your power, manage your power supply for three phase. On lighting circuit of three phase, make sure it doesn't go above below 388. That is your voltage range for lighting circuit. All right. Now, then for um, lighting circuit of 230 volts. Okay, 230 divided by 100 is going to be times 3. So it's going to be 6.9. So when we are working with lighting circuit, make sure that your voltage drop does not exceed 6.9. Okay, so let's say we minus 6.9 from 230 minus 6.9. So we are going to be working with 229.1. So make sure you manage your voltage within this range when you are working with lighting circuit. All right, we are supplying lighting circuit. And for us to do all that, we need to have the design and drafting concept before we manage this. So I'm going to introduce a particular exercise for drafting, design and drafting. So we're going to do a kind of design and drafting. I told you I have a setup training for design and drafting. Those of you that are coming from higher institutions or electrician or engineer, I will show you a practical step, the basic of design and drafting, how you can design electrical project. Okay, we're going to do that. We're going to do that on highway. I will show you the subject. Then the next one here is 4%. 4% is now referring to the entire system, the entire installation. Okay, your entire installation, you have various output here. You have various circuit, you have lighting circuit, you have power circuit, you have whatever. You have a lot of circuit and signaling and control circuit, power circuit, lighting circuit. The whole of your system installation should not drop above 4%. 4% of the declared voltage. Okay, if you are working with 400 volts, let's say 400 volts here, you have a supply within your project, within your installation. Now, this one is going to be divided by 100 is what I have times 4. So it shouldn't go more than 16. Okay, so if I have 400 now minus 16, so they're now telling you that your voltage, your nominal voltage supply should not go below 384 volts so that your circuit and your installation and your appliances or your equipment will work safely and optimally. All right. So make sure you manage your voltages within this stipulated range. That is what we are telling you. So your power demand of this particular project you are doing, all the apply apparatus and the circuit and your equipment and appliances, all the consumption total, as you put them on, you take your readings. As you put down on, you take your readings. So the final voltage drop when everything is working shouldn't drop more than 4% of your declared voltage. Then if you are also working with two single phase 230, it should not also drop above 4%. Okay? All right. So that is what this place is trying to clarify. All right. Now let's quickly do some, like I told you before, some industry and some electrical setup. They've not done what we call industrial revolution. And you will not do that when the need has not arise. It is when you now need a change. You need to upgrade your installation. That is when it is necessary to carry out industrial revolution. So you will not do industrial revolution because some change has been made for cable color code and so on. But if the necessity, if inevitably your system demand upgrade, and that upgrade now has to go with some to effect some changes on regulatory body. If you have to do that, no issue, you can do that. But if the lifespan of your apparatus and your installation they are still intact, they are not due for change, but you want to carry out alteration, you want to carry out upgrade by adding more advancement to your installation or installing new equipment, or you want to expand your installation by installing some equipment and other apparatus. If you want to do that and you are doing that with the new color code and you still have existing old color code in your system, so you want to make a joint, okay, to create a room for the alteration. So this is what you do. This is your old color code that is that has been working, and you want to merge, you want to install carry out new installation exercise, and you have new color code that you purchased. You want to link them together. So this is what you do. You are going to do them this way, join them this way. You join them and sorry, you're going to join them, but when doing that, you should understand their colors. You should understand their colors. So this is how you make your joint. Red is going to join with brown. Yellow is going to join with black. Blue is going to join with gray. Black is going to join with blue. So this is what you do. This is your line 1. This is also line 1. This is your line 2. This is also line 2. Uh, Sorry, let me put them this way. Okay. This is your line 1, line 2, line 3, neutral. The same way, line 1, line 2, line 3, neutral. So you join them this way. So this is how you merge old color code and new color code. Okay. Then, like I said before, if you are working with a single core cable, this is how you make your neutral and your live cable arrangement. Blue remain your neutral, brown will be 3. Then here, black 3 and neutral blue. Okay. Line 1, line 2, line 3, neutral. Line 1, line 2, line 3, neutral. Then for single phase, brown and blue. Okay. All right. Now, we have a lot of changes made since 2008, like I told you. I recommend this book, especially for students. I recommend you buy IET. I told you that IET is the Institution of Engineering and Technology. We no longer use the acronym of IEE. The acronym has changed to IET. Okay. IET stands for Institution of Engineering and Technology. And you can also get to register so that whenever you want to buy those books I want to recommend to you, you can buy them at a subsidized price. Buy them at a subsidized rate. As a member, you can get some discount. All right. Now we are going to do a design. We're going to do a design so that you know how to, you will learn how to do voltage drop calculation. All right. Voltage drop. Then for those of us aspiring to go into design and drafting, you need these books. This is your book. This particular book is for calculations for designers and for electricians. This book will allow you to enable you understand how to design electrical project, all the associated calculations within your design, you find it here. Okay, you can also get these books from Amazon. All right, Google them from Amazon, you get them. Then there's what I need. I need to also advise you on something: certification. As an electrician, as an engineer, you need certification. Certification will allow you to sell your competence, to market your competency, and also your value on the labor market will also increase if you are certified electrician or a certified engineer. How do you get certification? If by registering this body I told you about, the IET, these books, I buy them from IET, except this. This one is for National Electrical Code. This is for US regulatory body. Okay. So I also have exam preparation for my students who are coming from IET, from low voltage, 110 voltage countries. So I prepare them for exams, for NEC exam. So I teach them about their own regulatory side of organization. So this is the exam preparation book. If you are writing exam under NEC, so if you want to get certification, you prepare yourself here. The preparation will enable you to know your ground, to know your capability, your competency within the framework of your electrical practices. Okay, so if you are preparing for certification under NEC, you need to purchase this book. You can buy them from Amazon. Okay, then if you are preparing for certification under IET, you need to buy this particular one. This one is for IET, for exam certification, and for you to get recognized in electrical trade. Okay, you need certification. There is no doubt about that. Okay, so you need this book exactly one, two, three, four, five. Okay, you can get them online from Amazon. You can also get them from IET website. Like I told you, I'm a member as well. So there is a benefit for you to be a member. If you are a member, you are going to be given a mentorship. They will assign two people to you that will mentor you. Like me, the way I do, whatever thing I want to do, if I want to go into training setting, I want to do any innovative career that I want to go into, I always discuss with my mentor. So he will guide me and also give me the best path to follow. Okay. So that is what, yeah, I will also advise you, because why I bring up this particular exercise is because so many questions have been coming requesting for how to get certification and how to get electrical books. I have a lot of electrical books I will recommend, but I don't know if it is allowed here. Why I give you this one is because I'm a member of this particular authors. Okay, this one is coming from our IET, like I showed you my membership card before. So this is what is obtainable. This is what I want to bring to your notice today. So if you register, you can also get the books from Amazon, like I said before. Then, or you register as a membership, they will subsidize the cost for you. You can now buy, but you need those books because they are strictly for design and electrical grounding. You know, you need them so that wherever you are going, whether you're going to control or you're going to automation or you're going for electrical installations, you need those drafting and design books, and you need those books, IET also, and the IET book that you use them for reference. Like I told you about the changes made since 2008. If you go through those books, you see all the changes made, all the design characteristics, your load demand, your diversity factors, your okay. Let me show you one other book that, as a designer, I need this book as well. This on-site guide. Okay, all the tables you need for design, your voltage drop, your current carrying capacities, your diversity table, your multi-story building, load sharing, everything you need for your design and drafting, you can find them there. Okay, so you need those. Now let's go to our design. We're going to do design in our next exercise now. All right, we are done with this. Let's go for our design narrative. Now we are going to put up a design now. Highway lighting project. That is what we are going to design now, so that we apply voltage drop calculation to that, so that you know the method of using voltage drop formula. Okay. All right. Um, some of my guys, they are not aware about this voltage drop calculation and how to apply it. And power analysis, you're going to do a kind of power analysis, how to determine the whole of this. Okay. So the project now, I try to put up this narrative, is highway light project. We're going to design this project. So let me read it now. Let's design lighting illumination system for 500 meters road distance with the following elements. We're going to design a street light, a highway lighting system. Okay. So we are given these two elements. One, we need two 50-watt light fittings. So we are told that we're going to design this across 500 meters distance road, that is half kilometer. This design will cover half kilometer distance for lighting illumination. Now, I want us to do it in such a way that a particular pole is going to contain two of these 250-watt. All right. I want the pole to have two lightings, two fittings, one face left, one face right. Okay. That is the method I want us to design. Then we're going to also incorporate photo cell so that at night the light comes up automatically. Then in the morning by 6:30 or thereabout, the light will shut down by itself as well. So we're going to do that. We're going to incorporate photo cell function. Then still on that project, we're going to determine the following. Uh, we're going to determine the following. One, number of poles to cover that distance of 500 meters. Number of fittings, supply voltage, main circuit cable sizing, branch circuit cable sizing, incomer breaker sizing, branch circuit sizing, contactor sizing, voltage drop calculation. We're going to do that. This is what we need to do. Okay, that is step one. Step two, we're going to design this. I don't know if my software will have some of those components. I will check. We're going to design it, a kind of generating the diagram, the connection method, and simulate it. Okay, we're going to do that design in my software, control software. Then we're going to simulate it. You know, the advantage of simulation is that um, after designing, you're expected to go to the site and implement that particular project. But before then, we now have to do a pre-test, like pre-test if the project is going to function or is going to fail. So that is why we use simulation to simulate the project. That is the essence of using simulation software. So we're going to do the design. I know I may not have a sufficient tools to draw the pole and draw the lighting. But what we're going to do, we're going to use normal pilot lamp to represent the light system. So we're going to design with a pilot lamp. Okay, let me show you what we're going to use. We're going to use something like this. Normal lighting system that I've been using with you guys. We're going to use this type of light to change, or can as well use 3D choose. We're going to use either this or this to make the design, okay, and simulate so that it will light up. And look for photo cell. I have photo cell, then we simulate it, okay. So, but now we're going to start from designing first. Let's design first. These are the parameters we need to work with. So this particular video is due. So we're going to use another video to start up um, the design. All right. Okay. So whenever you see the video, I'm going to title it part one, part two, because we can't finish it in one exercise. We're going to do two exercise. Exercise one, we start from somewhere, then when it is not complete, we enter a second video. Okay. All right. Thank you. Now let's start with the designing process. Okay.